Hi, and welcome to today's lesson. We're going to be going over adding and subtracting polynomials, examples 5 through 8. Okay, so just continuing from last video's lesson, we're going to go ahead with example 5. Okay, so this one says find the degree of the following monomial. Again, this is a monomial. All it is a combination of coefficients and variables. To find the degree of a term. By the way, this is another word for this monomial is a term, right? So all the monomials within a polynomial are also called terms. To find the degree of a term or a monomial, you simply have to add the exponents present in that monomial. So here, what do we have here? We have 2 and we have 4. The exponent, or I apologize, the degree of a coefficient is always going to be 0. So the reason is because 10 can be rewritten as 10x to the 0th power, where anything raised to the 0th power is 1. So you just get back 10. Okay. So whenever you're trying to figure out the degree of a monomial in a polynomial, you don't really have to consider the coefficient. So in this one, since the degree of, since the exponents present is 2, 1, and 4. Okay, I forgot to mention the 1 on top of the b. So the monomials present in this, the exponents present in this monomial is 2, 1, and 4, which would mean that the degree of this monomial is going to be 7. Okay, let's try example 6. And this one says to find the degree of the following polynomial. To find the degree of the polynomial, you simply have to find the highest degree present in out of all the terms in the polynomial. So all you have to do is count up the exponents and then find the highest one for each monomial. Now, the important part of this is that you have to simplify the polynomial first before trying to figure out the degree of the polynomial. So as you can see in this one, here we have negative 6x to the fifth x to the fifth power y, and then positive 6x to the fifth power and y. So since these have opposite signs, they cancel out. Okay, so simplified, this polynomial boils down to 3x cubed and y squared plus 2. Okay, so the degree of this term is 5. And as I've mentioned before, the degree of something like a constant is 0. Okay, so the degree of the whole polynomial then would be just 5. Moving on, let's try example 7. So this tells us to add 12x squared y plus 3xy squared minus y cubed plus 2 and negative 2x squared y plus 2y to the third minus 3. Okay, so all we're doing here is think of it as just combining like terms. So does 12x squared y have a like term? It does not. So you can just pop it out. So that one goes away. 2xy squared, does that have a like term? It does not. So we can do the same thing. Y cubed does have a like term. So that's a like term and that's a like term. So 2 and negative 1. So positive 2 and negative 1 is going to give you positive 1 or just y cubed. Okay, so we can cross those off. And then we also have this term, which doesn't have a like term associated with it. So you can just pop it out. So 2x squared y. And finally, the negative 3 constant. So that one doesn't have a like term either. So this is going to be our answer. Okay. All we're doing is basically, when we're adding, we're just combining like terms. Okay, example 8. Now, with subtraction of polynomials, okay, subtraction, you have to be a little bit more careful. So here we have negative u squared minus 5uv plus 4v squared, and it wants us to subtract that from this polynomial, 3u squared minus 2uv minus 2v squared minus 7. Because this says from, you're going to have to write this polynomial first, okay? We're subtracting this from that, okay? So let's write down our problem, 3u squared minus 2uv minus 2v squared minus 7. Okay, and we're subtracting. And here's the part where you have to be careful. When you're subtracting polynomials, obviously you have to use this negative sign or subtraction symbol. But what's happening is we're subtracting this whole thing from this whole thing, which means we have to surround this polynomial with parentheses in order to not make any mistakes. So let's go ahead and do that. We're going to make sure that we have a parentheses, and we're going to, inside the parentheses, we're going to write our second polynomial, 5uv plus 4v squared. Okay, and the reason why it's important to surround the second polynomial with parentheses is because this negative sign, or these, okay, let me like make this a little bit more clear by putting the first polynomial in parentheses as well. This negative sign or subtraction sign has to be applied to every term. That's what the parentheses helps us to do. Okay, we're distributing the negative to each term in the second polynomial, which would reverse the signs of all the terms. So let's go ahead and do that. So what we end up with is positive u squared, right? Because we're multiplying negative by negative, and also a positive 5uv and negative, right? We're multiplying negative by a positive. So we're going to get a negative 4v squared. And then the first polynomial, we can just pop it out of the parentheses, since there's nothing in front of it, no negative sign multiplying it. So 3u squared minus 2uv minus 2v squared minus 7. Okay, and now, just like we've done before in our previous examples, we can combine like terms, okay? So 3u squared, does this have a partner? Yes, it does. Okay, so both of them share a variable with an exponent. So 3 plus 1, that's going to give us 4. So 4u squared. We can cross those off. Negative 2uv. So this has like term with 5uv. So negative 2 and positive 5 is going to be positive 3. So positive 3 uv. So we can cross those off. And lastly, we have negative 2v squared and negative 4v squared. Okay, we have two negatives, so we can add it. So negative 2 and negative 4 is going to give you negative 6. So negative 6v squared. And then lastly, we have this negative 7, which we can just pop off. Okay, and now we have our final answer. I'm going to rewrite this in descending order. In other words, from largest to smallest, it's going to be 4u squared minus 6v squared minus 3uv minus 7. And this is our answer. So once again, just to remind anyone who's watching this video, when you are subtracting, okay, when you are subtracting polynomials, it's very important to surround the polynomial that you're subtracting from the first polynomial with parentheses so that you can distribute this negative and reverse your signs, okay? This will prevent any mistakes related to this type of problem. So always use parentheses and surround that second polynomial, okay? Thank you.